Okay, so here's problem number 43 from section 5.4. We're finding the total area. And as we mentioned before, whenever we see these total area problems listed in the assignment, we need to put our antennas up and we need to make sure that the total area, we're looking for that negative area problem that could happen. All right, so what does this graph look like? Do we have a problem with negative area? I'm going to rewrite this as y is equal to x times x squared minus 3x plus 2. Can you make sure I did that correctly? All right. This factors as x and x looks like negative 2 and negative 1. Do I have that right?
Yeah.
All right. So I'm thinking about this graph. Let's do it over here, I suppose. If I do this graph, I've got a 0 at 0, I've got a 0 at 1, and I've got a 0 at 2. Agreed? And it is, as x gets really, really big, it's positive. So I think I have something that looks like this. That's my guess at what that cubic function looks like. I know that there's a sign change at each of these roots because they're all singular roots. I know that when x gets really big and negative, I get a negative value out of here. Yeah, I think that's what I have. So if I want to know what the area between 0 and 2 is, I'm going to have to break this down into two integrals. One from 0 to 1 of x cubed minus 3x squared plus 2x dx. And then, since this is quote-unquote negative area, I'm going to subtract that by the integral from 2 to 3 of,
1 to 2.
sorry, 1 to 2. Thank you for that correction. From 1 to 2 of x cubed minus 3x squared plus 2x dx.
Is it okay if we write it as like adding that absolute value?
You can, but we don't know what the antiderivative of an absolute value is. So, although you can write it that way, you don't have the ability to apply the fundamental theorem of calculus part 2 to that problem if you do it. Yes, if you do, by the way, if you put it in your calculator, you simply can put absolute value of that function, and you'll get the same value out.
What if you did absolute value of the entire
No,
interval?
that won't do it. You have to do this is equivalent of the integral of the absolute value of y dx, which is not equal to the absolute value of the integral of a to b y dx. This one will take account of the negative area. After you subtract it off, you had that negative area, take it down to 0, and let's just give you the positive value of that. This is what you would need if you want to get it out of the calculator without a lot of work. May?
Since the area from 0 to 1 looks like fairly similar to the area from 1 to 2.
It looks similar. Is it the same?
Maybe. It's freaking.
Maybe. It may be the same. So your question is essentially, could I just take this and double it?
Yes. No. I don't know what you want me to say. No, because there's one positive, one's negative, it's going to cancel out.
Well, it would cancel out if this was a plus here. If they were the same area, this would be the positive area, this would be a negative area, and indeed they would end up becoming a 0 if they're the same area. Do you know, or do you only suspect, that this area here and this area there are the same? Where are you on that?
You could suspect.
Yeah, you could suspect.
Like intuitiveness.
Are you willing to bet a letter grade
Right now?
that
Yes.
you're... Now this means you're willing to bet let's say you earned an A, but I'll only give you a B because you bet a letter grade.
Or would you raise me a letter grade? No, I'm just kidding.
You ready? Mang. Actually, you're right.
I mean, no.
It is true that this is totally symmetric, and these areas are going to be the same. We're going to see that in a second.
No, I didn't.
Are you ready?
I didn't take the deal. I don't want the deal.
Man, you were right. You should have
Right.
taken the deal.
No. This is 1/2.
You took it out.
Man, you just said you were right.
I was right.
Oh my god.
Yeah, the areas are probably 1/4 each of them.
Okay, and by the way, let's go back to what we said. We expect that this curve is negative,
The deal again.
so we're going to subtract off the negative quote-unquote area. And again, 1/3 x cubed minus, nope, let me try that again. 1/4 x to the 4th minus 3/3 x cubed plus 2/2 x squared is evaluated from 1 to 2. Would you please double check my work to make sure I did that properly?
Yeah, I don't know what you're.
I just wrote 2/2 to just make sure that you can see the process that I was using to find the antiderivatives of these. I was increasing the exponent by 1 and dividing by that power. So I'm going to get from this section 1/4 minus 1 plus 1 minus 0 minus 0 plus 0. That's a 0. Minus. See, 2 to the 4th is 16. 16 divided by 4 is 4. 2 to the 3rd is 8. 8 times -1 is -8. 2 squared is 4. Minus
You just break that.
1/4 minus 1 plus 1. Would you double check all of my work to make sure I did that properly? Looks good? All right. So what are we going to get for our final answer? These ones cancel, leaving me a 1/4. These two 4s and this -8 cancel, leaving me the opposite of -1/4, or another -1/4, or my final answer is 2/4 or 1/2. And again, Meg, you are absolutely right. Your intuition was correct. Those two areas are indeed exactly the same.
How does this answer work?
Because this area is 1/4, that area is 1/4. So 1/4 plus 1/4 is equal to 1/2. If we were to do the integral normally, where we add these two things, this would have been 1/4, this would have been a -1/4, and it would end up being a 0.
Okay, yeah, I knew that.
But they didn't ask what the integral was. They asked, what is the total area?
Okay.
All right. Is everyone complete with this problem? Great.